Today we will see how to get multiple digital input and multiple digital output using this Pico board. For doing this, we will do a project where we will turn on two LED using two buttons. So for this we will use GPIO pin 15 and GPIO pin 16. So by using this pin 15, we will try to turn on a red LED, and using pin 16, we will try to turn on a green LED. First, let's look at the circuit diagram. So as a circuit diagram, we will connect the LED to GPIO pin 0 and GPIO pin 1. So I am just erasing this one to show you how we are going to connect the real circuit. So what we will do is we will use a resistor, then the LED, then it will go to the ground. Okay, so this is the LED and this will go to the ground. So this is the red LED. Again we will connect a resistor, then I'm very bad at writing the LED. So this is the green LED. Okay, and this is the ground. And for the button we will use GPIO pin 15 and 16. So let's say we are connecting one side of this to 3.3 volt and another side this here. And for this also the same, one side is to 3.3 volt and another side is to GPIO pin 16. So pin 15 will be used as red and this will be used as green. So this is all for the circuit diagram, but as I show you in my previous video, there is some problem for the debouncing, so we need to connect some pull down resistor here. So we need to connect a pull down resistor like this, but Raspberry Pi Pico has some internal pull down and pull up resistor. So for today's we will use this internal pull up and pull down resistor. So right now we don't necessarily need this pull down or pull up resistor. Okay, and so let's connect the buttons and LEDs to this Raspberry Pi Pico according to the circuit diagram. So for doing this, I will first connect the ground and positive to this breadboard's ground and positive rail. So I am connecting this pin number 38, which is the ground pin. So to the ground, let me just see this. Okay, so I connected this to the ground here, and I will connect the pin number 37 to the positive rail. So this will be used as a 3.3 volt source for the button. I will also connect all other pins and LEDs according to this circuit. I'm done with connecting the circuit. So I connected this button to the pin number 15, so it will be used for turning on the red LED, and this button I connected to pin number 16, which will be used to turning on this green LED. And I also connected another side of this button to this 3.3 volt rail, as you can see here, because previously I connected this 3.3 volt to this red line, so this is now connected to 3.3 volt. So when I will press this button, the digital IO pin will read 3.3 volt and it will be read as 1, because in digital 3.3 volt is 1 for the Raspberry Pi Pico. Let's now do the coding in Thony. So I connected the Pico board to the computer, and let's just try to confirm it by clicking here, and if I choose this compute 7, then you will see the Pico file system here. So this is the Pico file system, and be basically working here. And I made one mistake during connection of the 3.3 volt pin. This will be pin number 36, not pin number 37. So I just made this correction here. So I changed this one. So you can just change it. Then I open a new file, as you can see here, and let's try to save it. So I'm saving it to the Pico board, and I am giving it a name multiple IO. Okay, so automatically it will take the extension .py. You can also give it during the naming. So first let's try to input the machine library from this one. So I am using import machine, and also I am importing the EU timer. So because we will be using only the pin functions, we can say from machine import pin. Okay, now let's define the LEDs and button. So for the red LED, I can say this is attached to the GPIO pin 0. So I'm attaching to the GPIO pin 0, and this will be an output pin. So it will be pin dot out. And then I am just copying this for the green LED. So the green LED will be connected to GP pin 1, and it is also an output pin. So then the button, so the red button, it is connected to pin number 15, and this is an input. So I will write pin dot in. And for the green button, it is connected to the pin number 16 as an input. So I will change it to the green button. And just don't forget to add the input pull down register here. So I will use pin dot pull down. Let me just try to see if I make this pull down correctly. Let's try to run it. So it says there is something wrong. I guess this pull down. Okay, still it's not good. I think everything will be capitalized. Pull down. Here we go. This is the correct one. So I am just copying this one for this pin also. Okay, so I finished inputting all the necessary libraries and declaring the input and output pins for the red and green LED, as well as red and green button. And don't forget to use this input pull down for the button input. Now let's write a while loop, because this loop will run continuously. So I'm just making this while as a true. So for reading this, as I said, if I press any button, this will connect to the 3.3 volt, which is digital 1. So I can say if this red button dot value equal 1, that means if the red button is pressed, then we can just first try to see it in the console window. Print red button is pressed. So first let's try to see this one. So as I said, so if we now run this one, then if I press this button 15, it should print red button is pressed. So you see red button is pressed for multiple times, because in my previous video I showed you this is because of the debouncing. So you need to add some sorts of delay here. So I am adding a delay of 0.1, that means 100 milliseconds. Also for removing the debouncing, we are using this pull down register. So both of them help to remove the debouncing and floating point issues. Now let's stop this problem and run it again. So if I now press this one, let's try to see what happens. So you see it now says the button is pressed. Still it has issue. If I press once, it's reading this button for twice. So we can just increase this delay to 200 milliseconds. I think now everything is correct. Let's just confirm it again. So I am just pressing pin 15. It says the button is pressed. So it's now working perfectly. So you need to be careful about this debouncing issue and this delay time. Now let's try to turn on the red LED after this button is pressed. So I'm just deleting this one. So after this delay, I will use red LED dot value. So if this value is 1, then the red LED will be turned on. So let's try to see it. So I'm now pressing this button, and you see this red LED turns on. So if I press it again, nothing will happen, because every time I press this button, it's turning on this LED, and it keeps its condition if I don't press anything. So if I don't press any button, this LED will be always turned on. And if we try to turn on this green one, we can do the same coding in this while loop. So we just need to make some indentation here. So this will be green button. So if the green button value is 1, then it will turn on the green LED. So let's try to see this. So as you can see, without pressing, still this red LED is on, although I loaded another program. I loaded the edited program, but this LED is still on, because the Raspberry Pi Pico always holds its previous value. So previously it was turned on. As long as the power, as long as the power is turned on, this it will keep its previous value. If I remove the USB cable and connect it again, then you will see this LED will be turned off. Let's just try to see it. So let's just remove this from here. So I remove the USB from my laptop, and then I am reconnecting it again. So you see, I connected it again, and the red LED is turned off. So I can just choose my port again, and if I run this code, okay, so if after running this code, now you see both of the LEDs turned off, because while there is the power, it can retain the previous state of the GPIO pin. Just be careful with this one. So if now I press this button 16, the green LED will be turned on. Also if I press this button 15, the red LED will be turned on. And if I again press both of them, nothing will happen, because it keeps retaining the previous GPIO state. So to just make more confirmation about this one, let's try to turn this green LED off. So I am making an addition to this program, and I am stopping this and loading this one again. So even though I run this code again, both of the LED is turned on, because they are just in their previous state before loading this code again. So if I now press this GPIO pin 16, then the green LED will be turned off, as you can see from this code. Yeah, so this is all for using multiple input and multiple output using the Raspberry Pi Pico. But let's just make it more good. So if we just click this red button, then only the red LED will on, and if we press the green button, then only the green LED will on, other LED will be turned off. So this is pretty simple to do here. So when the red button is pressed, the red LED will be on and the green LED will be turned off. Let's just add this here. And when the green button is pressed, the green LED will be on and the red LED will be off. So this is pretty simple. Let's just run it. So I run this program again, and if I now press this green button, so you see the green LED turned on, but the red LED is turned off. If I press this red one, then the red LED is on, but the green LED is off. So if I press the red multiple times, nothing will be changed, because every time a red LED is turning on while the green LED is turning off. But if I press this one, then it will change the switch. So in the if condition we can set any condition according to our necessity. So that's all for today.